Hello and welcome to Chemistry with Mr. Olson. Today we're doing Experiment D, which is in our green Review of Chemistry Labs packet. Experiment D. And you put a silver nitrate solution in a flask with a few drops of indicator. Silver is an unusual transition metal. It always has a +1 charge. Nitrate, NO3 with a -1 charge. We're going to write the balanced equation. So down here, 1 AgNO3, 1 to 1, it's a +1 and -1, and it is, of course, aqueous. And that's our first reactant. Silver nitrate solution with a few drops of indicator. You slowly add a calcium hydroxide solution. Calcium is an alkaline earth metal in group 2. It has 2 valence electrons. When it's ionic, it's always a +2 charge. And hydroxide is a -1 charge. So that's an aqueous solution as well. So that means, leaving space for a coefficient, Ca and 2 hydroxides. So we put that in parentheses, and we have our 2 reactants. There we go. And what happens? Well, at first, we notice a precipitate forms. A precipitate is, of course, a solid that forms in liquid solution, aqueous solution, and we keep adding calcium hydroxide until the solution changes color. So then that indicates a change in pH. And next, we filter the contents of the flask by pouring the mixture through filter paper, which catches the precipitate. We rinse the precipitate and then let the filter paper dry overnight. The next day, we weigh the filter paper and precipitate. Okay, so what causes an indicator to change color? A change in pH. Now, it's different for different indicators, but that is true. And when we run the experiment, we collect this lab data. We have the original volume of calcium hydroxide and the remaining volume, the mass of the filter paper, and the mass of the filter paper plus precipitate. So we can calculate, for example, the volume of calcium hydroxide solution used. That's, of course, the difference between what we started with and what we ended with. So showing our work, 82.0 milliliters minus 15.3 milliliters will give us our remaining volume. It looks like 11 minus 5 is 6, and 7 minus 1 is 6. So 66.7 milliliters. Okay, and similarly we can calculate the mass of the precipitate. We have 2.81 grams minus 2.55 grams, the mass of the filter paper. So our difference is, let's see, 0.26 grams, whatever that precipitate is. Now, figuring out the precipitate, well, we need to figure out our chemical reactions. And there's 2 steps when we create a balanced chemical equation. The first is to get our substances right, and then once we do that, we then go on to balancing the equation, which means finding the coefficients that work. So first, we've got to predict these products. We have 2 ionic couples here, cation, anion, so they're going to swap partners. So Ag is now paired with OH. AgOH. And that's got some phase. We're going to leave that for now. Plus our other product, calcium nitrate. So leaving space for a coefficient. 1 Ca plus 2 for every 2 NO3 minus 1s. And we have a hint here. The next question asks, what's the precipitate? But all nitrate-containing compounds are soluble in water. So this calcium nitrate is soluble. It's aqueous. So that means our silver hydroxide must be the precipitate, which means its phase is solid. So that's our precipitate, AgOH. And that's the substance. Now, we've gotten the 4 formulas right, but we now need to balance the equation. So getting out our pencil, it's always a good practice. Let's see, 1 of these, 2 of these, but we have 2 hydroxides on this side, so let's try out 2 hydroxides there. That means 2 silvers, which means we have 2 silvers there, 2 nitrates, balanced. That was pretty easy. Now finally, we come to the last question, which is, using the mass of the precipitate that formed, calculate the molarity of the calcium hydroxide solution. Now, hint, use stoichiometry. Actually, that makes sense because the precipitate that formed, that's AgOH, but it's asking us something about calcium hydroxide, so that's a different substance. So, using the mass of the precipitate that formed. Well, we formed 0.26 grams of the precipitate, AgOH. And now we're going to use that quantity, grams to moles, We're going to figure out how many moles of calcium hydroxide we used. Let's see. We'll get out of grams of AgOH using the molar mass of AgOH. That is adding up silver at 107.9, etc. We're going to get into moles of AgOH. And molar mass is always grams per 1 mole. And then we don't really want to be talking about AgOH. So we're going to get out of moles of AgOH, and we are going to get into moles of what we want to be talking about, which is calcium hydroxide, CaOH2. And we need that to calculate the molarity. So we get that mole ratio from our balanced chemical equation. How many moles of AgOH? 2 moles of AgOH. Correspond to how many moles of calcium hydroxide? 1 mole. It's a 2-to-1 ratio. So that's our mole-mole ratio. We have the molar mass. That will give us a number of moles of CaOH2. Now, of course, the question didn't ask for moles of calcium hydroxide. It asked for molarity. So this is our next part of the calculation. The molarity equals the moles over the liters equals, and now we simply substitute. We know the moles of calcium hydroxide. We just calculated that. And we know the liters. Well, we know the milliliters. We'll have to convert from milliliters to liters. So we'll get out of milliliters into liters. We know that 1 liter is 1,000 milliliters. So that'll give us the liters, and that will give us our final answer, the molarity of the calcium hydroxide solution. So nice way to write that is molarity of CaOH2. So of course we have to get that number. 3 sig figs is always a good option. So I hope that was helpful, and have a good evening. Let's see. Ta-ta.